looking at product rule. Product rule from the name, it implies multiplication. So if you have, let's say, y equals to two functions, u multiplied by v. So what's going to be derivative? Derivative has to be dy dx equals, pick one of the function, let's say u first, then differentiate the other. So you have dv dx. Then multiplied, sorry, not multiply, plus, pick v, then differentiate the other one. So du dx. So you have u dv dx plus v du dx. Alright, so let's take an example. Let's say you have y equals 2x squared plus 2. Then you have 3x plus 4. So how do you differentiate this? Let this be u and let this be v. You can see two different functions multiplying each other. So you have your u now becomes what? 2x squared plus 2. And your v becomes 3x plus 4. Alright, so differentiate this guy here. You have du dx becomes what? Of course, 2 times 2 is 4. That's 4. X 2 minus 1 is 1. So you don't need to write the 1. Then if I differentiate 2, I'm getting 0. So that's it. Then dv dx becomes 3. If I differentiate 3x, I get 3. If I differentiate 4, I get 0. So that's all. Now, the formula for product rule is dy dx equals to u dv dx plus v du dx. So basically what that means is that if I do this method, if I'm using this method, I can basically just say this multiplied by this and this multiplied by this. Okay, then we have u, what's our u? I'll use 2x plus 1. That's 2x plus 2 rather. Then what's my dv dx? My dv dx is 3. That's multiplied by 3. Then plus my v. What's my v? 3x plus 4. 3x plus 4. Then what's my du dx? My du dx is actually 4x. Okay, so I can open up this bracket by saying dy dx now becomes 3 times 2x. You have 6x plus 6 plus 12x squared. Then plus 4 times 4x is 16x. So I can collect like times by saying that 12x squared, and then I have 6x plus 16x. That's about 22x. 22x plus 6. Okay, so that's the derivative of that. That's how to differentiate using product rule. Okay, so let's take another example. So looking at this function, and this is a product of product function. So I'll just do, let this be u and let this be v. So my u now becomes 5x cubed plus 2, and I have v equals 3x squared. So I'll find the derivative of this function. Du dx becomes 3 times 5 is actually 15. Then x, 3 minus 1, you have 2x squared. Then the derivative of 2 is 0, so I don't need to write that. Then dv dx becomes 2 times 3 is 6x. Then minus 1 is just 1, so I don't need to write that again. And so my dy dx becomes, what's the formula again? U dv dx plus v du dx. Okay. And so I have, what's my u? My u is 5x cubed plus 2. 5x cubed plus 2 multiplied by dv dx, 6x plus v. What's my v? My v is 3x squared multiplied by du dx. And That's 15x squared. Okay, so I have 6 times this. I have 6 times 5 is 30. Then x raised to power 3 raised to power 1, that's raised to power 4. X raised to power 4, then plus 2, this is 12x. Then this multiplied by this, 3 times 15 is actually 45. X squared times x squared is x raised to power 4. So collecting like terms, we have 30x plus 45x raised to power 4. And that's 75x raised to power 4 plus 2x. So that's our derivative, dy dx. Okay, so that's how to do that. So let's take one more example before we call it a day. All right, so let's say y equals 3x squared plus 4 all raised to the power of 3, then another function 2x plus 2. So let's say this is our u and this is our v. So u becomes 3x squared plus 4, and our v becomes 2x plus 2. So what's my derivative of this function? Du dx. Du dx becomes 2 times 3, you have 6. 6x, 2 minus 1, what you get is 1. I don't need to write that. Plus 4, if I differentiate plus 4, I should get 0. So that's gone. What's my derivative of this function? Dv dx. So if I differentiate 2x, what should I get? 2x is 2, then 2 is 0. So that's basically gone. So dy dx from chain rule is actually u dv dx. You should be familiar with this formula by now. V du dx. And that's actually this multiplied by this, and that's u is 3x squared plus 4, then multiplied by dv dx, and that's 2, then plus v. What's my v? This is my v. 2x plus 2. Then what's my du dx? This is my du dx, 6x. So open up this bracket. What I have is 2 times 3 is 6x squared plus 4 times 2 is 8 plus 6 times 2 is 12x squared. Then 2 times this, you have 12x. Okay. Then open up this bracket. What I have is collecting like times 6x squared plus 12x squared. That's 18x squared, then plus 12x, then plus 8. Plus 8. So this is the derivative. This is the dy dx. So can I do this with my head? Yes, I can. So can I do this with my head? Of course, I can do this with my head. So what should I do? Differentiate this. What should I get? I should get 6x, right? If I differentiate this, I should get 2, right? Good. So, sorry. No. This is a function of function, right? So that means I have to bring this here back, and that'll be 3. Differentiate this inside. I have 6. 3 times 2 is 6x multiplied by 6x, then into 3x squared plus 4 all raised to the power of 3 minus 1 is 2. Then if I differentiate this, I should get 2. So this multiplied by this, I'll get 2 into 3x squared plus 4 all raised to the power 3, then plus all of this multiplied by this, and that's 2x plus 2 into this time this is 18x all to the power of 3x squared plus 4 squared. So I can now start to simplify the the function and open up the bracket, I'll get the same answer.